There are a few good ways of solving Kirchhoff rule equations, so I would like to do a couple different examples. This first one I'm going to call Classic Kirchhoff. And to do this, I'm going to need to start off with some kind of a circuit. Let's do this. And maybe we can give these batteries some values. We'll go 10 volts, 8 volts, 6 volts. And I'm going to call these battery 1, battery 2, battery 3, and then we can do resistors too. R1, R2, R3, R4, R5, R6. It's a lot. So I would like to start by drawing currents running through here, and it doesn't matter which direction I choose for my currents. I actually don't have to be right about any of this, which is really nice. I just have to pick a direction and then go with it. It's a good idea, I think especially, to draw currents in the directions that a battery wants to push. So this first battery wants to push current upward, and I think let's go with that. I'm going to call that my I1 because it goes through resistor 1. That's here. All of that's I1. All of this is I1. Anywhere where there is not a chance to go a different direction, that's all I1. I2, this battery wants to push upward. So let's call that I2. I just kind of started with the biggest battery and worked my way from there. Now I've got this junction over here, and at that junction I need to have something coming out. I've got current 1 goes in, current 2 goes in, so I'm going to have this current go out. Otherwise I've got 3 currents going in, and I can't do that with nothing coming out. This is R4, so I'm going to call this thing I4. Down here I've got 2 currents coming out. I need some current going in, so let's go right here. Have that be the current going in. I'm going to call that I5. Next spot, I've got another battery. That battery wants to go up. There's no reason it can't. So let's do that. We'll call that I3. And now I've got this junction. I've got 2 things coming in already. I'm going to have something go out. So there is that going out. I'm going to call that I6. I now have 6 unknowns. And if I have 6 unknowns, I'm going to need 6 equations. Let's see what I can do. Junction rules, those are easy. So let's do those first, as many as I can. I've got a junction right here, and at that junction I have I1 coming in and I2 coming in. So I have I1 coming in, I have I2 coming in, and together those make I4. So together those make I4. That's my first junction. I like to color code these different currents because I think it makes it a whole lot easier to see at a quick glance where my equations are, what I'm coming from, all that. I've got this junction here. At this junction I've got I4 coming in. I have I3 coming in, so plus I3. And together they make I6 coming out. So we'll do that. And there is I6. That's that junction. I've got this junction. I have I6 coming in. And coming out of this, I have I3 going up. and an I5 coming out to the left. And then I've got this junction. I'm just showing all the junctions right now. I5 comes in, and it splits into 1 and 2. I have right now 4 junction rule equations. I can use up to 3 of those. So 1, 2, 3, 4. I'm going to be able to use up to 3 of them, so I'm going to cross one off right now. Now I need some loop equations. My loop equations, these are the ones where I start in one location and make my way around. So if I do that, I want to have loops where my current goes in one consistent direction. What I mean, like red to blue doesn't work because current was going clockwise and then all of a sudden counterclockwise. That's not going to work. But if I did green to pink over here, I could do that. So let me do a green and pink loop. I'm going to pick a spot to start. I like to pick right before a battery, so I'm going to do that. And I'm going to start moving up. First thing I encounter is that battery. And then I've got a resistor, so I'm going to subtract a resistor. That is an I3 times R3. I keep going. I'm up here. I get to this resistor. I'm going to go minus I6 R6. Keep going, and I'm doing the green-pink loop, so I'm back here. I hit my starting point. I'm at the end, so equals 0. That's one closed loop. Let's see what else I can do. I could go blue, purple, pink, yellow. So blue, purple, pink, yellow. We'll do that for a loop. I'm going to start right before a battery. E2 minus. I go up, I hit this resistor. I'm going to have a I2 R2 minus. Keep going. I get here. I've got I4 R4. Keep going. I6 R6. Keep going. Yellow. I5 R5. Keep going. I'm back to the starting point. Equals 0. 1, 2, 3, can't use 4. So 4, 5, I need one more. I can go red to purple to pink to yellow and back to red. So I'm saying red, and I've already actually done most of this loop, but that's okay. Purple, pink to yellow. I'm going to again start right before this point. So the first thing I hit is my battery, and that is an E1. I start moving, I hit this R1. So I'm going to get a minus I1 R1. Keep going, purple, minus I4 R4. Keep going, I get here, minus I6 R6. Done that one, keep moving, get to this yellow resistor, minus I5 R5, and I'm back to the start, equals 0. There's that. Now one thing I didn't talk about, and I should have, if I had a second battery here, call this thing E4, right now that battery is working together with, so this would be an E1 plus an E4. If I did not have it facing that direction, if I had a second battery here, E4, then as I loop back around, I'm going to end up with a minus E4 because that battery is working against me. The resistors, when I keep track of my direction, when I say I want an always clockwise loop or an always counterclockwise loop, that kind of a thing, then the resistors will always be negatives, which is really, really nice. And there will always be, because of junction rules, there will always be mathematical guaranteed enough loops so that you don't have to have some loop where the current doubles back on itself, so that you don't have to use that. So that's it. I've got 6 equations, 6 unknowns. From here, I'm going to have to figure out a way to solve it, but that's a separate video.